Devlin. Please welcome her.
Hi. Bonjour, je m'appelle Catherine Devlin. Bienvenue à See Docs Run, Run Docs Run. I hope that came out right. That's all the French I've got. But thank you. All these slides are already online at tinyurl/rundocsrun, and I will give that URL again at the end, and it has links to my GitHub repo and everything else you're going to need. So that's the only part that you'll need to write down, and you don't even need to write it down yet. So this talk is on executable documentation, which is a term that I just made up, so I better define it. I'm talking about documents that pull in real living code and execute that code, and the results of that execution either validate or get incorporated into the document when you generate that document or refresh that document, or even when the reader is reading the document. As for what a document is, I want you to think really broadly here so I can get away with being in the education track. Yeah, I'm talking about, I wrote this package, here's how you use it, but I'm also talking about educational documents, like here's how you learn to program, here's how you do this science problem, here's how you do this math problem. Or organizational documentation. Here's how you request a new laptop. Here's how we do our builds. Here's how you request funding to come to PyCon. These are all kinds of documents that can actually benefit from having code embedded in them. Why are we bothering? Aren't docs perfect? Well, docs aren't perfect. Bunch of problems with them. This doesn't address all of them, but it addresses some of them. One of the big problems is inaccuracy that results from forgetfulness. You think, OK, now I'm going to write the docs, it works like this, and you've already forgotten some of the details of how the program works, and you write inaccuracies in. Or it was accurate to begin with, but then time passes. The code changes, the organization changes, and you forget to update the documents. Also, there's boredom. Most of us love to code. It really engages our brain. We get focused on the problem, and we do a fairly good job of writing code. And documentation is more like a chore. We kind of resent it, and that boredom shows through, and the boredom spreads to the reader, and it's just not that engaging or relevant or fun to read. So what we end up writing is historical fiction. It wasn't even true to begin with. It's progressively less true, and nobody's interested in reading it. Now, I've never read this book, but it sure looks like it sucks. So coding your documents can help fix this problem, both in that the document can become self-verifying. The document lets you know when it's false, or the document cannot be false because it's pulled straight out of live working code. Also, because it's code, your brain will re-engage. It wakes up, it gets back into the problem, it writes something that's relevant and that you care about, and then the reader will end up caring about it, and the quality of your documentation will improve. So to illustrate all this, I made up a fake little package called Argument Clinic, and we're going to just run through how we might document up some usage samples and checking on the software requirements. We're going to do that with 4 different technologies, and because that's a lot to cover, we're going to be going fast. The examples are going to be really simple, but I want to cover some of the basic boilerplate of using each of these, and then you can decide what might suit your project. So the oldest one is doctests. This goes back to a previous millennium, lost wisdom of the ages. The idea of doctests is simply that your doc strings can and should include usage samples. Those should show the user how you use a piece of code and what the result should be that they can expect. Now, in this case, here's a piece of code where clearly the code is not complete. It's not going to succeed at both of these. It will answer this first one correctly, but it's not going to respond the way our doctest suggests it should, or our docstring suggests it should. And doctest's job is to go through, pluck out those examples in docstrings, and let you know when they fail. So this is just a verification technique for your docstrings. Docstrings get kind of a bad rap from testing snobs because they feel like it's not a good, complete, rigorous unit testing solution, and fine, going to concede that. This is orthogonal to your unit testing solution, not competing with nose or py.test or anything else. Instead, I'm renaming these to executable docstrings. Now the word test isn't even in there. And the whole point is simply to make your docstrings relevant and accurate and more interesting and enjoyable to read. So those have been around forever. Next technology up, Sphinx, is more recent, and this is actually part of why the documentation in the Python world has improved a ton, because Sphinx takes a bunch of restructured text documents and generates a complex, but not overly complex, tree of documents that can refer to each other, that includes searchability and indexability, really a pleasure to read and a pleasure to use. Sphinx in itself isn't exactly what I'm calling executable documentation, but there are some really worthwhile plugins for Sphinx, extensions rather. For instance, the doctest extension does exactly what the regular doctests module does, but it does it against your Sphinx document. It comes with Sphinx, so all you have to do is say that you want it as you're setting up each Sphinx project. I'm popping into the directory where, all right, here's a restructured text document that uses it. That big chunk in the middle there is just, it looks exactly like a doc test you might use in a regular piece of code, but it's included in this doc test directive. And once I've done that, when I build my Sphinx doc and I include the magic word doc test, the extension is going to run through there, grab those doc tests, and run them just the same way the doc test module itself would, and give me a complaint, and thus verify that the usage samples I put in my Sphinx document are in fact still up to date. Sphinx also has an autodoc extension, which will go through the doc strings in your code, pull them into your Sphinx document, and the Sphinx doc test extension understands what the autodoc extension is doing, will see those doc tests that have been brought in that way, will recognize them and execute them. So that'll be another chance to execute those doc tests and verify that it's working. Another possibility, this one is not included with Sphinx, it's called Autorun. So you have to go through a few steps, first to install it and then to enable it within each Sphinx project. But the idea is that once you've done so, you can create these run block directives and then have a literal block that this looks a lot like a doc test, but what is missing is the response. Instead of predicting what the response should be and complaining if it's wrong, this leaves the response blank and lets that get filled in at the time that we build the doc. So here we're using the package, but we're saying nothing about the response. When we make this document, what we get, now the responses that the program provided are mixed in there into the document. There's one option. Another extension, very, very similar. Oh, I'm sorry, we have a little more to show on Autorun. The other interesting thing, here I just whipped up a package that can probe the system, find out what the requirements.txt are, whether the system meets those requirements, and then I can invoke that from within my document. So here's a kind of a live requirements document. I can also go all the way outside of Python, all the way out to the console with this runblock console command, and execute a command line. Like I'm going to ask what Postgres version I'm running. Sorry, my co-presenter, Chelnik. So the result of that, here we've checked on what documentation we've got and on what Postgres version we're running. All right, another very similar extension is called program output. Again, you need to install this and enable it. And the basic working is really, really similar. But in this case, you have a couple of choices. You can either use program output or command output. You can't go directly into Python. If you want to call Python from here, you have to do it as if you were at the command line using the Python command. But let's take a look at the result that gives. Pretty similar. The difference is with the program output, you don't actually see the command that was used to generate it. Whereas with command output, the command that we issued gets echoed back. Just a couple of options. Tons of advantages to Sphinx. It generates this lovely structure. It's really become the Python standard. You can host Sphinx documents. Well, they're actually plain HTML, so they're really easy to host. But you can also host them at Read the Docs for free. And then the Sphinx ecosystem is huge, very rich, all sorts of extensions and options, and yet it's not too hard to get started with just right off the bat. I'm going to give shout-outs to a couple projects that I don't really have time to cover, and they're a little bit off the beaten track, but one is called Literate Resting. It's really pretty similar to what I was showing before, these Sphinx extensions, in that it takes a restructured text doc and lets you go out and insert external code. against one restructured text doc at a time. It doesn't hook straight into Sphinx. That's not a Python program, but Titus Brown did it, so it deserves an honorable mention anyway. And then Sphinx contrib auto program is a very limited but nice program that just goes out. If you use argparse, it looks at your program's argparse and pulls that documentation into Sphinx. So that kind of counts as a version of executable documentation. Next big technology. Is there anybody here who isn't yet jittering with excitement over the IPython Notebook? Anybody? Good, good. All right, as well you should be. I am not going to try to compete with the fantastic keynote by Fernando yesterday. If you haven't seen it, definitely watch the video. I am just going to remind you that every IPython notebook is, in fact, a beautiful example of executable documentation, as I've been talking about. Because every single cell in that notebook can either be a markdown cell, which will be interpreted into a good-looking piece of document, or a code cell, which you can execute and get the results right there. And of course, because it's IPython, you're not limited to Python. You can use the exclamation point and go outside to the system. So this is doing what those Sphinx extensions were doing it really fast and easy. When it comes to ease of integrating the documentation part with the code part, you really can't beat this. Every single cell, all you do is say, oh, OK, this one's a code cell, this one's a markdown cell, and that's all there is to it. Oh, I made a change. That's why it's complaining. IPython notebooks, you have a bunch of options for serving them. You can certainly serve them yourselves. NB Viewer is supplied by the IPython project. Basically, if your notebook is saved out there on the web anywhere and has a URL, then you pump that URL over to NB Viewer. And let's see if... And then it's hosted online. This is a free service. Now, in this case, it's a static copy of the document, so the user can't actually use it live. But they can always download it and then run it on their own machine if they like. And then Continuum Analytics will let you host a notebook live at wakari.io, again, for free, at least for a certain, I'm not sure what their cutoff is or how their funding works. But so you have all these options for hosting, and the IPython Notebook is kind of the most executable documentation, because not only do you get to execute it when you generate the document, the user can execute it while they're reading it and see what's actually true on their system. In fact, they can jump in and experiment with these code cells, try things out so that you can be introducing a concept to them in the documentation part, and their work area to try it out and experiment and learn things is right there in the very same window. Their brain doesn't have to switch gears as they move back and forth between other windows. Amazing, amazing tool. Now, the notebook that I've shown, really basic, really dull, but the IPython project has some amazing tools out there. Look at the main NB Viewer site, which hosts some great-looking notebooks. There's a gallery of interesting IPython notebooks. Likewise, really expands your brain with some of the possibilities. I'm just going to quickly show you one notebook that was used to generate a textbook, a piece of educational material. So if you want to know if I'm going to squash up the size a little, if the notebook can do the sort of rich output that you need for what you're looking for, the answer is almost certainly yes. So not only does it have all this, the user can go and mess with things. Yeah, really easy integration between the code and the document. The user gets to experiment and all these hosting options. Definitely want to check out the IPython Notebook. Last technology. I think I'm rushing from nervousness, so forgive me. Dexy. Here's the only one you probably haven't heard of. Add a guess. This is a framework for applying various transformations to documents. That sounds kind of meaningless. But we'll get it installed, and then we'll try it. There's several steps to using it. First, you need to run setup to build kind of the infrastructure that you need in the directory. Then you write up your source text files. These can be either restructured text or markdown. Then you need to write a recipe. And that's just a text file that tells dexy what transformations you want to apply. Finally, you run the dexy command itself to generate the document from all this source. So here's an example of a source file that's going to run through dexy. It looks pretty similar to what we've seen before, but now, oh, I wish, hang on, can I crank that font size up? No, it's rather resists having the size cranked up. Sorry about that. What we have here, this looks like a Jinja2 tag, and in fact, it is a Jinja2 tag. And it says we want to go out to dexy and have it grab a document and include that in here, and then pipe that through its own indent filter. In dexy, each of the transformations are referred to as filters. So basically, we want the raw text of this script, and then we want it again, but this time, we're grabbing the text of this script, and then we're piping it through the Python filter. In other words, run it through Python and get the results, and include that right here. And then we're going to do something similar on the software requirements. Finally, we're going to go out and use a bash script and pump the results of that pump the bash script through bash itself to execute it. And we're going to insert those results right here in the paragraph. And dexy is the only tool that makes it easy to insert your results wherever you want them in the document. They don't need to be in separate blocks. They can be right there in the flow of the text if that's what you want. So let's see the result. Oh, I'm sorry, I forgot, the recipe file. The next thing you have to do is say to dexy, all right, for all the restructured text files you find in this directory, please apply Jinja so that the tags work. And then there's a couple of filters that basically set up some sane defaults for an HTML page. And then these indented items, those represent requirements that are required for the RST file. Namely, you're going to need to pump the Python files through the Python filter and the bash files through the bash filter. So finally, once we've done, oh my goodness, not a problem. I thought I had that going. Let us, which window is this? Haha. Oh, I know it. Oh, that's right. I beg your pardon. I remember what I have to do. I included the link right here. There we go. All right. Here's our result. So we have the text of the Python program, and then we have the result of the Python program. Here we didn't ask for the text of it. We just asked for the result. And here we have requires blah, blah, blah. You have PostgreSQL, and this is the result of that bash script inserted directly into my paragraph. All right, let me back up a place. All right, advantages of dexy, you get a huge variety of transformations. In fact, I meant to put this in a slide, but let's, I mentioned that each of these transformations is called a filter in dexy. So dexy has a lot of available filters. Oh, goodness. OK, yeah. It has almost too many. And dexy, although it's written in Python, the code you're executing doesn't have to be in Python. So if you're doing a Ruby or a CoffeeScript or who knows what, you can pipe it through any of those as the filter and document up whatever language you're working in. And you have really the most complete control of your output. So if you have really exacting demands on what the output is going to look like, you very well may need to end up using dexy. But I got to admit, this is the hardest one to work with. I was up kind of late last night because dexy was doing some last-minute betrayal on me. So you're going to put more work into this if that's the way you need to go. There's a dexy reset command that you will probably need to fall back on sometimes because dexy caches, and either there's a bug or I'm bad at using it and it keeps on thinking that it should reuse cached material that I have refreshed. Also, here's irony. The documentation for dexy is incomplete. What? OK, whatever. Nonetheless, an extremely powerful tool. So I've shown you mechanics of really basic Hello World style wrapping code into documentation, but honestly, that was not the most important part of the talk. This is the most important part of the talk, which is where you use your imagination to apply these techniques to all sorts of problems, all sorts of documents that you write. Almost anything that you write that's on a computer could benefit if you think about it imaginatively. For example, don't just assert what Python versions your code runs with. run talks and include the results of your talks run right there in the document? How about living lecture notes where the student can experiment as they read without even breaking away from your text? That would be an IPython Notebook technique. And in fact, I've used that to teach. It does work very well. How about tutorials that actually assist with configuration? Obviously, they would need to install your document first, but then the tutorial could look at the system, see what they have, and help talk them through what else they need. Or a troubleshooting document that doesn't just say what the problem might be, but that examines the system and tries to figure out what the problem might be. Don't just say, this needs 2 gigs of memory. Say, this needs 2 gigs of memory, and I see that you only have 1 gig. Maybe that's the problem. How about dashboards that don't just give you statistics and facts about the system, but include the text explaining the relevance of those statistics and those facts? How about organizational documentation that responds to changes in the organization? So it no longer says, see Joe for a new laptop once Joe's user account disappears from the system. How about compliance documentation? For those of you who have to do PCI compliance documentation or government compliance documentation, that actually can verify itself. Don't just assert that the data is hashed in the database, for example. You can query the database in the document and verify that. Tons of possibilities. I hope that your imagination will get fired up, that you will start to include these techniques in documents you write in the future. And I hope that your imagination will work on some questions. The GitHub repo is right here, and all the slides are right here. Plus, of course, you will be able to find them on the Python website. And I finished way early, so if you don't have some questions, you're going to have a long break. Thank you.
Hi, great talk. I was wondering, so I'm writing a software where we have in the documentation a tutorial of how to install the software and the steps, the files to create for the configuration and so on. And maybe I'm missing something. I was wondering if we could run this tutorial against like a test, if there was a solution for that, for creating files, changing those 2 lines and so on.
Yes, I do think that you should be able to do that if you can. The trouble is, of course, that the user is first going to need to get enough installed so that one of these techniques will work, so that they will need to have a little bit of, they'll either need to have the notebook or whatever the technology is. But at that point, you could definitely have a document that then...
Oh, no, I was wondering if there was a way to make sure that the tutorial is still valid. Like, we don't have to update the tutorial. Like, if every time we do a commit on our software, we run the tutorial against the software.
I see, yes. Well, for instance, if it's Sphinx, then every time you run make HTML, it's going to execute those. If you're using like the Autorun or proga output, that will in fact execute every time you run make HTML. So if you can run a make of wherever that fits into your workflow, generating the document, it will confirm that live. Does that?
Exactly. And what I was wondering if there was a tool for. Because here, like, there are great tools for doctests and for Python testing, but what about bash testing, modifying a file, adding this file? And so, for example, there's the tutorial is asking create this file at this exact path.
Yes.
Is there such tool?
If you're, let me think. You can write up, say, if you wrote up a bash script that would look at their system to see if they'd followed these tutorial steps, then you could include the result from that in a document. Am I close to what you're getting at? I'm not sure.
Not really. I think we can chat about that later.
Yeah, we might need to later on, because I'm sorry, I might be missing the point.
Okay, that's all right. Thanks.
Okay, thanks. Well, I will catch you afterward.
Sure.
So
I guess I actually have a very similar question. So we shouldn't write documentation that is tests, but if we're putting code in our documentation, can any of these tools test the expected results? I mean, if we put a doc test, but if we say, I don't want my documentation to say not implemented or value error or something.
In that case, the doc test extension to Sphinx would be a good one in that it doesn't throw ugly things into the document. It just verifies that what you have is what you expected. So that might be the way you want to go in that case. There's probably a way to, I'm sure you could hack up the other techniques like the notebook to do that too. But yeah, the doctest extension would be the easiest way to approach that.
Just quick answer also to this. If anybody knows about Seaborn plotting library on top of matplotlib for IPython notebooks, so that guy wrote little script which tests if notebook produces the same output as before, right? So if you create a document using IPython notebook, you can just rerun it, and it would verify that the output is the same. So it's a simple solution for that.
Very good. And isn't that in, oh gosh, there's a repository of IPython Notebook add-ons. Is that, do you know if that's where that is?
I just saw it in Seaborn itself. So if you go GitHub, just search for Seaborn, and it's beautiful plotting library, guys. So based on Panda. So if you want really quick overview, and there is tutorials on that and how he analyzed Titanic data using Seaborn, just really going step by step. Oh, but that's already divergent. So he has the tool.
Seaborn for verifying that an IPython notebook is not giving you weird, unexpected results. OK, thank you for that.
So question, could you use dexy as a preprocessor for Sphinx? Basically keep the output as a restructured test and then incorporate that in the Sphinx output.
You can, in fact, do that. And that would be one way to still use Sphinx. And
you could have some additional options for how to incorporate live data from your system via the dexy app.
Excellent example. Yeah, yeah, because your output format from dexy doesn't have to be anything. You can just put it right back into restructured text and then process that from there. Thank you for a great example.
So like you said, we've all seen IPython Notebook do like insanely mind-blowingly awesome things. Has anyone tried to integrate that into Sphinx so that you can get all those cool like spinny charts and like sliders that make regraph things? I mean, some of that probably wouldn't be possible in a static environment, but like, has anyone tried to get to like, I guess, get some of that IPython magic into Sphinx?
Yes. Usually the answer to has anyone tried is yes.
OK.
But I don't know. OK, I'm going to throw this one out there. I don't know of such an example. Does anyone know of one? Is anyone staying for sprints? That would be a really interesting project, and I can't tell you. But
OK.
Thank you.
Thank you.
OK.
One other interesting tool to look at here is another Sphinx plugin called Manuel, which lets you, instead of displaying your doc tests as doc tests, it allows you to show them as code snippets, which for more complex examples can be really helpful. Manuel as in the waiter from Faulty Towers.
Manuel?
E-L, yes. I had to put PyPI in there as well to find it on Google.
Interesting. OK, well, thank you for the recommendation. So there is somewhere out there a Sphinx Manuel extension that will give you other options for running the doc tests. OK, so let's see. My contacts are giving me trouble under the glare. I think that's all the questions we have. Am I right? OK. All right. Thank you. And enjoy the rest of PyCon.